This video is about central angles, arcs, and arc addition. So first we need to do a little more vocab about our central angle and arcs. So a central angle is an angle whose vertex is at the center of the circle. And in this case, our angle measure is going to be equal to our arc measure. So for example, we would have the measure of angle AZB is going to be equal to the measure of this part of the circle right here, which would be called arc AB. An arc is an unbroken part of the circle. So it's going to go from a couple of letters that represent part of the circle. So for example, we could have arc AB, or we could have arc BC, or we could have going from A all the way to C, and we could have arc ABC. So let's learn a little bit more about our arcs. So a minor arc is a mark that is so it's always going to be inside the central angle, which means that it always has less than 180 degrees. So 2 points always define a minor arc. So for example, a minor arc would be like AB. A major arc is an arc that is outside the central angle, and it's always going to be more than 180 degrees. And it uses 3 points. So for example, a major arc here could be A all the way to C to B. So we would name that as ACB. We want to use the letters in the order that we're traveling around the circle. And then the last type of arc, which you've probably heard of before, is a semicircle. And a semicircle is half of a circle. So it is intersected by the diameter, and it's always equal to 180 degrees. So it uses 3 points to define it. So in this case, if DF is the diameter, one of our semicircles then could be DEF. So let's identify the type of arc given that MP is a diameter. So the first one is NQ. Well, NQ only has 2 letters, so it has to be a minor arc. The next one, PQM. When you have 3 letters, you need to follow those letters around the circle as they're listed. So P to Q to M. Well, P and M is a diameter, so this right here has to be a semicircle. MQN. So M to Q to N is larger than half the circle. It's 3 letters, so this has to be a major arc. PN. So from P to N is 2 letters. This has to be a minor arc. And then we have P to M to Q. So P follow to M follow to Q. It's larger than the semicircle, so it's a major arc. So now let's use this idea to help us find the measures of some of our arcs. So in this case, we have circle C, and AD is a diameter of the circle. So before we do anything else, we're going to find the missing measure. So we know that A to D is a diameter, so this part of the circle right here has to be 180 degrees. And to get the missing part, we can do 180 minus 117 to get that this is 63 degrees. So now we can find our measures. So if we have the central angle of 117 degrees, then the arc of AB also has to have the same measure, so 117 degrees. The arc of BD is intersected by this central angle, which is 63 degrees. And then our last one is BAD. So B all the way to A to D includes this semicircle and this arc right here. So we're going to add those together, 180 plus 117, which will get us 297 degrees. So let's try the same thing in number 2. Before we start doing anything, we're going to find the missing angles. So if AD is a diameter, this is 180 degrees. And when I subtract 72 to get that missing angle, has to be 108 degrees because this is my other semicircle. And together, those have to equal 180. So if I'm looking for arc AB, I'm using this central angle. So AB has a measure of 72 degrees. Arc ADB, so A to D to B is using this whole part. So we're going to do 180 plus 108, which gets us 288 degrees. And the last arc is BDA. Well, D and A is a diameter, so this has to be 180 degrees because it's a semicircle. So arc addition postulate. It's just like segment addition, now it's just arcs. So we're adding the small arc plus the small arc is going to equal the whole arc. So for example, if AB was 50 degrees and BC was 25 degrees, then the whole measure would be 75. So let's use that information to find some of our arcs. So I know that if PQ is 41 degrees, this angle right here is also 41 degrees. And we need to find a couple of our different arcs. So the first arc we need to find is PQ or PR. So PR goes from here to here. It's intersecting both of those arcs. So the measure of PR is going to equal 41 plus 63 degrees, which will get us 104 degrees. The other arc that we are looking for is RTP. So R to T to P. Now, another way, an easier way to find this is that we know a whole circle has to be 360 degrees, and we're not including the part we just found. So the measure of RTP is equal to 360 minus the arc we just found, which gets us 256 degrees. So let's try again number 6. So number 6, the first thing we need to find is YZ or YV. So YV is those two arcs together. So the measure of YV is 92 plus 23. And when we add those together, 92 plus 23, we get 115 degrees. The other arc that we are trying to find is XUV. So XUV includes everything except for that 23 degrees. So we can subtract from 360. 360 minus 23 gets us 337 degrees. So in this case, it gives us that QM is 5x plus 3, MN is 3x minus 9, QN is 58 degrees, and QPN is 23x plus 112. So we need to find all of the arcs in this circle. So first we need to solve for x. So I have 5x plus 3 plus 3x minus 9 is equal to 58 because this is arc addition. So piece plus piece equals 58. So we get 8x minus 6 equals 58. We can add 6 to both sides and divide, so we get x is 8. Once we know x is 8, we can substitute in to get all of our missing measures then. So when we have 5 times 8 plus 3 is 43, 3 times 8 minus 9 is 15, and 23 times 8 plus 112 is 296 degrees. Number 6, we know that xy is 10x plus 120. We know that xv is 5x plus 10. And we know that yxv, this whole arc, is 12x plus 60. So we can add the two arcs together and set them equal. So 10x plus 20 plus 5x plus 10 is equal to 12x plus 60. We can solve for x, so we have 15x plus 30 equals 12x plus 60. So we can subtract 12 from both sides and subtract 30 from both sides, and we get that x is 10. Now that we know x is 10, we can substitute. So 12 times 10 plus 60 is 180 degrees. So we want to know, is YUV 180 degrees? Well, if part of the circle is already 180 degrees, then the other part over here also has to be 180 degrees. So is it a semicircle? Yes, because it's 180 degrees.